Nothing is more precious than fresh water. It's an integral and crucial part of our natural environment and supports all of Florida's treasured ecosystems. It's the primary resource that sustains life for millions of organisms, including ourselves.
Florida is a land blessed with an abundance of water. It's essentially everywhere we look, both on and below the land surface. On the surface, we have more than 1,700 streams and rivers and more than 7,800 lakes. Below ground, water is found within a few feet of the land surface just about everywhere.
Florida's aquifer systems, the underground layers of rocks and sediment that hold and transmit water, are some of the most productive aquifers in the world. We've grown dependent on these aquifers for our fresh water supply, largely because they have traditionally delivered very high-quality water that requires little, if any, treatment. Today, more than 93% of Florida residents, approximately 14.8 million people, rely on groundwater for their freshwater needs. In total, we use more than 4 billion gallons of groundwater every day. This makes Floridians more dependent on groundwater than residents of any other state in the United States.
Beyond our personal use, groundwater is also a crucial component of our economy. In Florida, more than 35% of groundwater usage is devoted to agriculture, more than 10% to commercial and industrial uses, and nearly 5% for the irrigation of recreational lands, such as parks and golf courses.
Though we use so much groundwater and are so dependent on it as a resource, we cannot see it because the reservoir is underground, in the void spaces in the rocks and sediments. The amount of water in the subsurface and the rate at which it moves are hard to measure. This is true just about everywhere except in Florida's springs.
Springs are windows into the aquifers beneath our feet and a reflection of the purity of the water flowing through them. They are locations at which groundwater visibly flows to the land surface. They provide crucial habitat for wildlife, including the Florida manatee. Throughout Florida's recent history, springs have provided settings for human habitation, such as Paleo-Indian sites and modern towns and cities, because they provide a consistent source of fresh water. Florida's springs have been considered by many to be places of healing and mystical powers, such as Ponce de Leon's elusive Fountain of Youth. Today, they have also become an important recreational resource used by the millions of people every year that come to the springs to experience the clear, clean, fresh water. Florida's natural springs discharge more than 8 billion gallons of crystal clear fresh water each day. Geologists have recognized more than 700 unique springs in Florida, such as Silver Springs in Ocala and Wakulla Springs south of Tallahassee, that are marked by crystal clear pools visible from the land surface and even satellite imagery. In addition to the ones that can be easily seen, geologists estimate that several hundred springs exist beneath rivers, lakes, and oceans. This represents perhaps the largest concentration of freshwater springs on the planet. Florida's largest springs discharge from the Floridan Aquifer System, which underlies all of Florida and extends into parts of Alabama, Georgia, and South Carolina. It is among the most productive underground aquifer system in the world and supports more than 1/3 of the largest springs in North America. Hundreds of Florida's rivers and streams receive groundwater from springs and seeps. Vast amounts of surface water and groundwater also sustain numerous lakes and wetlands throughout the state. Thousands of natural habitats and the survival of millions of organisms depend on the lifeline of clean freshwater provided by Florida's aquifers.
There's a fixed amount of water on Earth, most of which, approximately 97%, is salt water contained in the world's oceans. Of the remaining 3% that constitutes the world's freshwater supply, less than 1% exists in the world's lakes, rivers, and streams. 77% is locked up in the glaciers that engulf the polar regions, and the remaining 22%, the largest usable reservoir of fresh water, lies beneath our feet in the form of groundwater. All of the water on Earth is in constant motion, largely driven by the heat of the sun. Evaporation causes water to collect in the atmosphere that eventually falls from the skies in the form of rain or snow, and collects in the four major reservoirs: oceans, polar ice caps, groundwater, and surface water. Groundwater flows through voids in the rocks and sediments to surface water bodies like lakes, rivers, streams, and oceans, where it eventually evaporates back into the atmosphere. The layers of rocks and sediments that contain significant quantities of groundwater are called aquifer systems. Aquifers receive water through recharge areas where surface water can seep or flow down into the aquifer from the land surface. Groundwater that collects under the recharge areas flows to where it can discharge, such as springs, rivers, lakes, or oceans. In some places, aquifers are covered by rocks and sediments, like clay, that prevent or inhibit the downward flow of surface water. In these regions, the aquifer is said to be confined, and recharge can only occur through features such as sinkholes that cut through the confining material. These regions are typified by numerous rivers and streams that form because rainwater flows over land rather than seeping downward into the underlying aquifers. Where there is no confining layer, the aquifer is said to be unconfined. In these regions, rainfall seeps directly into the underlying aquifers, limiting the formation of rivers and streams. These are also the regions where the aquifers are most vulnerable to contamination.
The hundreds of magnificent springs that discharge groundwater from the Floridan aquifer system are a special type landform known as karst. Karst aquifers contain caves and conduits that transport water rapidly from sinkholes or other recharge areas to springs, in much the same way as rivers carry water from upland areas to lakes or oceans. Karst aquifers occur in regions like Florida that are underlain by limestone and dolostone rocks. Limestone and dolomite both dissolve in water containing weak acids, such as rainfall that absorbs carbon dioxide from the atmosphere to form a harmless solution of carbonic acid. In most regions of the world, and particularly in Florida, which has a large amount of vegetative cover, surface water absorbs additional carbon dioxide from decaying organic matter, such as dead plants and trees, thereby slightly increasing the acidity. Extensive cave development will occur where the surface water is rapidly introduced to the aquifer, such as in sinkholes and rivers that flow across unconfined regions of the aquifer. The aggressive surface water is so effective at dissolving the limestone rocks that many of Florida's rivers completely disappear from the land surface into caves that have formed in the transition zone between the confined and unconfined regions of the Floridan aquifer system. The Santa Fe River is a perfect example of this phenomenon. The river disappears from the land surface at Olino Sink near High Springs, Florida. It flows underground for approximately 3.5 miles to the river rise, where it comes back up to the land surface 40% larger than when it disappeared at Olino Sink. Once aggressive water enters the aquifer system, the naturally acidic solution dissolves cavities in the rock. Conduits are formed when the cavities become interconnected. Caves are formed when the conduits become large enough for humans to explore. Once the cavities become interconnected, the resulting conduits convey large quantities of groundwater to springs, where the larger conduits can carry more water and ultimately create larger springs. Dry caves such as Florida caverns arise when the water level in the aquifer drops below the level of the cave. For saturated caves, flowing groundwater continues to dissolve the surrounding rock, creating labyrinths of interconnected caves and conduits with passage geometries ranging from simple vertical and horizontal cracks to massive chambers hundreds of feet in diameter. Cave lengths vary from just a few hundred feet up to passages more than 4 miles long, such as those that have formed in North Florida near Tallahassee. The key thing to remember about the caves in Florida, regardless of length, is that most of them convey groundwater to springs. To effectively protect our springs, we therefore need to learn about the caves, map them, and understand how they collect groundwater from the surrounding aquifer and carry it to the springs. Florida's springs and sinkholes provide entryways to many of the largest underwater caves in the world. Several hundred caves have been explored and mapped in Florida, which has been a real challenge to the small community of men and women pursuing this endeavor because almost all of the caves are completely underwater. These underwater caves are devoid of light. The water is cold enough to cause hypothermia after short exposures, and the water often moves rapidly, which can make it hard or impossible to swim against the current. Once inside, inexperienced or unprepared divers can become lost in the labyrinth of passages that typify most Florida caves. Underwater cave exploration and research should therefore only be conducted by highly trained and experienced cave divers. Once inside the underwater caves, the divers have direct access to the groundwater system, where it is possible to see and measure groundwater flow processes that could otherwise only be studied remotely or in a laboratory. Here, research divers studying the Woodville Karst Plain cave system of North Florida for the Florida Geological Survey released a harmless dye into the groundwater flow system. This enabled scientists to determine how fast the water flows through the conduits to downstream sinkholes, as well as to measure other important aquifer parameters. Ultimately, that data will be used to develop models of groundwater flow through the entire watershed, which will help water resource managers protect groundwater quality at places like Wakulla Spring. Underwater caves also provide the habitat for unique creatures unlike those living in the sunlit terrestrial environment or even in above-ground caves. Cave-dwelling organisms called troglobites live in perpetual darkness. In underwater caves, tiny creatures such as blind albino crayfish and several amphipod and isopod species have adapted to the lightless aquatic environment. Troglobites rely on odors, movement, and chemical changes to hunt and scavenge organic material along the cave floor. They depend on the consistent environment provided by the underwater cave system, wherein changes in water quality or temperature can decimate an entire population. Many of these creatures have become so adapted to a particular cave's environmental conditions that they have evolved into unique species that only exist in 1 or 2 caves of close proximity. Scientists are hoping to learn a great deal from these cave creatures about species evolution, environmental controls on species development, and even the development of immunities to certain diseases. Unfortunately, more than 1/4 of Florida's aquatic troglobites are now threatened by deteriorating environmental conditions in the caves and springs.
Despite their magnificent beauty and importance to society, the springs and caves that make Florida one of the most unique places on Earth are now threatened with contamination and water level declines. As Florida's population continues to rise and land is increasingly developed, contamination and overpumping have impacted the aquifers and are now causing significant and rapid declines in the clarity and quality of the water in Florida's springs and caves. Researchers and water resource managers have observed a downward trend in spring water quality for more than 20 years. Groundwater is being contaminated by impurities that pollute surface water and enter the aquifer. Chemicals from fuel spills and gas stations, runoff from parking lots and city storm sewers, residential septic systems, pesticides and fertilizers from farms, golf courses, and lawn maintenance, and detergents and chemicals from households penetrate the limestone bedrock as easily as rainwater. Once an aquifer becomes contaminated, pollutants spread throughout the groundwater supply and impact the water quality of the springs. Some of these contaminant sources deliver nutrients such as nitrogen and phosphorus to the groundwater. The nutrient loading, in turn, causes a process called eutrophication in lakes, rivers, springs, and caves, causing the pristine natural conditions to degrade into an environment dominated by algae, bacteria, and other undesirable organisms. In addition to the degradation of water quality, many of Florida's springs are at risk of drying up as a result of overpumping of the aquifers. This occurs when groundwater is pumped out of the ground more quickly than it's replenished by recharge from rainfall. The condition is aggravated by the persistent drought that occurred at the turn of the 21st century. For the most part, overpumping problems are concentrated around large population centers such as Orlando and Tampa-St. Petersburg, where there's an increasing demand for fresh water. Overpumping in high-population coastal areas can also degrade groundwater resources due to the intrusion of seawater. The average Floridian uses more than 100 gallons of fresh water each day for household purposes, like washing dishes and doing laundry. That demand, coupled with expanding commercial and agricultural needs and climate variations, can cause reductions in groundwater levels. All of these factors have affected spring discharge. In extreme cases, some springs have ceased to flow altogether. Today, efforts are being made to protect these valuable natural resources.
The fundamental problem we have in Florida is one of balance. The balance between the growth and economic prosperity we want and the demands that those benefits place on our water resources. The alarming rate of groundwater degradation has captured the attention of the scientific community, the Florida legislature, and corporations who are focusing on protecting and remediating groundwater resources. Florida's Department of Environmental Protection is striving to protect Florida springs through the Florida Springs Initiative. This comprehensive protection effort is supported by both the governor and the legislature, who have allocated part of the state budget to initiate what is hoped will be a long-term effort supporting research, monitoring, education, and landowner assistance projects. The Florida Springs Task Force is a component of the Springs Initiative and is working to determine the status of Florida springs and to develop strategies for their protection. One of the major tasks is the delineation of spring sheds, which will define vulnerable recharge areas that contribute to springs. Another one of the fundamental missions of the Springs Initiative is to educate and empower the public so private citizens can take a proactive role in protecting our state's most precious natural resource. Research and exploration conducted through the Springs Initiative will provide the crucial data about Florida's underground drainage patterns, water quality, and hydrology needed to accurately define the spring shed boundaries. Spring shed maps will enable water resource managers to develop better land use policies that will more effectively protect aquifer recharge areas that are vulnerable to contamination.
Unfortunately, research and management alone are not enough to preserve our springs. Public support and involvement is imperative to the success of the Springs Initiative. Get involved. Learn what you can do to preserve your local springs. Avoid the improper use of chemicals that can degrade spring water quality. Be conscientious about water conservation. And attend local county commission meetings to let your representatives know that spring protection is an important component of good decision making. We as citizens hold an important key to the restoration and protection of Florida's springs.
With help from the public, the Springs Initiative is working toward a more promising future for our treasured springs, so that clean, fresh water will be freely flowing for generations to come.